Hello everyone. In this video, I'll be walking you through a Python program that compares two sorting algorithms, which is insertion sort and shell sort. We'll talk about how each sorting algorithm works and how the program measures their speed and which one performs better. And by the end of this video, you'll understand both algorithms and see their differences in efficiency. Now, let's start. At the top of the program, as you can see, we have import time and import random. We import time to measure how long sorting takes and random to generate random quiz scores. This is useful because we might want to test our sorting algorithms on different sets of data, sometimes entered manually and sometimes generated automatically. So this program basically helps compare which algorithm is faster when sorting quiz scores. Now, let's look at the insertion sort function. As you can see in the code, insertion sort is one of the simplest sorting algorithms. Imagine sorting playing cards in your hand. You take one card and insert it into its correct position among the already sorted cards. Now, to know what happens step by step, the loop starts at index 1 because the first element, index 0, is already sorted. 2. It picks the current element called key. 3. It compares that key with previous elements. If any element is greater, it shifts it in one position to the right. Once it finds the correct spot, it inserts the key there. This process repeats until the whole list is sorted. Now, insertion sort is easy to understand, but it becomes slow when there are many elements since it compares one by one, making it O and squared in the worst case. Now, we have shell sort. Now in this code, shell sort is like an improved version of insertion sort. Instead of comparing only neighboring elements right away, it starts by comparing elements that are far apart. For example, if the gap is half the size of the list, each element is compared with the one halfway across, then the gap gets smaller until it finally becomes 1, where it behaves just like an insertion sort. This idea helps move elements closer to the final position faster, which drastically improves speed, especially for large lists. In general, shell sort is much faster than insertion sort when dealing with more than just a few dozen items. Now, after defining both functions, the main part of the program starts here. First, it asks how many students took the quiz. Then, it asks whether you want to enter the scores manually or let the computer generate them randomly. Now, if you choose Y or yes, it asks you to type in each scores from 0 to 100 and validates your input, as you can see in this code. Now, if you choose N or no, it generates random scores automatically using this line. That's a simple list comprehension that creates a list of random integers between 0 and 100. Then the program prints the original scores before sorting, as you can see here. This helps us see how the list looked before applying the sorting algorithms. Now comes the performance test. This is where we compare both sorting algorithms. For insertion sort, as you can see in this code, we record the start time, sort a copy of the list, and subtract the start time from the end time. We use that copy parenthesis so the original list stays unchanged for the next test, We do the same for shell sort, as you can see this code too. Then we print the results of both using this code and their respective times. This too. This gives us a clear comparison of how much faster or slower each method is. And finally, the program checks which algorithm performed better by using this code. Usually, shell sort will be faster for larger inputs while for small lists both might take almost the same time. Then it ends by displaying the total score sorted using this code, which tells us how many elements were sorted in total. Now, to summarize our topic, insertion sort is simple and easy to code but slower for big data. Now, shell sort uses a gap method to speed up comparison and is generally much faster. The program shows how both work in real time and measure their performance in seconds. Now, this small project is a great example of how algorithm design impacts efficiency. Thank you for watching, and if you try running it yourself, test it with different numbers of students to really see the difference in speed. And that is all.